Okay, 6.5b, that section on middle of page 535 is division of radical expressions, which is the same as rationalizing the denominator. So remember when we had things like that and I had said you cannot have a radical in the denominator, you have to get rid of it. So you multiply top and bottom by a number so that when you multiply your denominators, you get your radical and you get a number, and there is a squared on that number. So when this and this are the same, then the radical and exponent disappear, and you're left with just the 2. So I've got square root of 6 over 2. Okay, simple enough, hopefully. So let's move into example number 8. And remember I mentioned a minute ago conjugates? This is where we run into conjugates. Now, one of the things that we had learned was if we have something like x minus 3 and the whole thing is under the radical sign, we multiply top and bottom by that, and that ends up getting rid of the radical sign. Okay, so we are rationalizing the denominator. We're getting rid of the radical sign. But notice there's a difference between this and this. Each one of these has a radical, which is very different, radically different than the square root of x minus 3. So we do this, multiply top and bottom to get rid of the x minus, or the square root sign. And on the ones we have here on the left, we use our conjugates. So whenever we have a radical plus or minus anything else, it could be a radical, it could be a regular old number like 3. But whenever we have that, we have to multiply the top and bottom by the conjugate. Whoops. So we multiply the top by 5 plus the square root of 3 over. Okay, so notice the signs are just the opposite of what this one is. So the top we get 6 square root of 5 plus square root of 3 over. Now what we do here is we square the first term. So the square root of 5 times the square root of 5 is the square root of 25. So that's actually 5. Then we take the square root of 3 times the square root of 3 and get the square root of 9, which is 3. So we not only made it simpler to work with, we also got rid of that doggone radical signs in the denominator. So this is actually going to be a 2. And see what we can do here. We can reduce 6 over 2 to 3. End up with 3 square root of 5 plus 3 square root of 3. And we're done with that one. Okay, so let's look at one that also uses conjugates, but is a little bit different. And we'll see if we can do this. Example 9. Okay, so we're going to multiply it by the conjugate. Whoops, not a plus, a minus. Okay, so my top is going to be that. I'll leave that alone. This one is going to be first term squared minus, always minus, the second one squared. Okay, now this one we can take the square root of. So instead of 25, we're going to have a 5. And the top, we're going to do the FOIL method. So let's do our first. It gives me square root of 25. And then we've got what our outside, minus 2 square root of 5. Then we've got our inside. Then we have our last. That's all going to be over 5 minus 4 is 1, so we don't even need that. We're done with the whole fraction thing. Okay, let's do some combining here. Square root of 25 is 5, and we're going to add this 4. So let's just make that 9. That gets rid of that and that. This, negative 2 square root of 5 minus 2 square root of 5 is negative 4 square root of 5. And we are done with that one. Okay, so just the key. You can use the FOIL method here if you want. You get the same answer. Or you can square this, 5, minus square this, 4. And then that's a real quick and easy way to get your denominator. If you end up with a radical sign in the denominator, you did something wrong, because by multiplying by the conjugates always gets rid of your radical signs. So you should be good to go after that. Okay, that's 6.5 done.